All right, so this is 6.7, and we're talking about triangle similarity. All right, and we're going to identify similar triangles and write similarity statements and show how two triangles are similar with the given information. All right, we're going to introduce a new symbol for you. So if you remember congruence, a congruent symbol, that's congruence, right? If you took away the equal sign, right, and you just took away that equal sign there, and you got this, that is similar. Similar. All right, so we're going to be using the similarity symbol in this a lot, right? So congruence, I take away the equal sign or the congruent symbol, and we now have a similar symbol. So if I said like triangle ABC is similar to triangle A prime B prime C prime, that's how I would do that. Okay. Let's see what, got blurry there. Okay, so another thing we're going to be using to prove triangles are similar are proportionalities. And remember proportionalities are kind of like scale factors after dilations, but they're just, simple fractions compared to each other, and you'll see that here in a minute. But we have to remember how to cross multiply also to kind of figure out later in the unit what we would need to do to identify other things or will have to be true for the triangles to be similar, but I think that's in like 6.8 or 9, I would imagine. So let's just go ahead. So remember, when two things are similar, right, they would have undergone dilation or something, right? The angle measures must be equal. Okay? Angle measures must be equal. Okay? And the line segments that make up the figures, or maybe just the line segments, if they don't have any measures of angles, right? They all must vary by the same proportion. That doesn't make sense. That's not even close how to spell proportion. Proportion. They must be proportional, right? So say I have like one line segment is like one block over and 2 blocks up, or 2 blocks up and 1 block over has a slope of 1/2, right? The other, at the longer one, would have to be like 2 blocks up for 4 blocks over, right? So it'd have to be like that. And here, let's show an example over here. Okay, under here, I guess, in quadrant 1. So we're gonna just kind of do our best to do what we can here. So we go 1, 2, 3, 4. It's 4 blocks over. Okay, and this angle, we'll do something like that. Okay, very, very basic right triangle. Okay, this angle is probably, who knows. Okay, but this is 4 over, and this is 4 up, right? So this is 4 over, 4 up. That means that this is 16. So So this is the square root of 32, right? 16 plus, that's 16, that's 16 square root of 32, that's 16 times 2, this would be 4 times 2. Alright, so that's 4 times the square root of 2. You don't know how I did that? Go back a couple and you'll see. Okay, so now let's see how if I make a proportional change in this, make it super easy. We'll do like orange is proportional. Go 1, 2, 3, 4, 5, 6, 7, 8, and we'll do 1, 2, 3, almost 14 minus 8 is like 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8. What am I thinking? It's late at night. One, 2, 3, 4, 5, 6, 7, 8. Okay, so there's our quasi-proportional. Make it a little better, nicer looking. My super advanced straight edge. All right, and then we'll make the hypotenuse here. And so that this is 8. This is 8 squared. Well, that's 8, and that's 8. So this is twice as long, so I'm going to go out and venture that this is 8 square root of 2. So that's how that would go. All right, so all of these angles, whatever this angle is, whatever this angle is, right, that's a 90-degree angle. This angle matches that angle. This angle matches that angle. But technically, since these are the same lengths, these angles would be the same angle, but I haven't taught you guys that yet. But we'll talk about that later, I suppose. All right, but these are similar triangles. I will call this A, B, C. I'll call this X, Y, and Z. And if I wanted to prove that triangle ABC is similar to X, Y, Z, there are a few ways to do it. Okay. The first way is with what we call the angle-angle theorem. Angle-angle theorem. It's kind of derived from the angle-side angle theorem, except it removes the side part, right? But since, if you have two angles that are congruent, then those two angles of a triangle, so it says, if two angles in a triangle are congruent, then the two triangles are congruent, or are similar, similar, right? So that might not be immediately intuitive, right? But if you think about it, we don't need the line segments to be all the same length for two triangles to be similar. Just all the angles need to be equal. And if you remember that the sum of the internal angles of a triangle equal 180 degrees, right? And you know that two of those two triangles have the same angles, then the third one must be the same angle, right? So say I have triangle 1, a triangle 1 here, I got triangle 2 here. It doesn't matter how long the lengths are, right? Say this one's bigger. This one's like bigger. Okay, it looks kind of similar. Okay, and this angle is this one, and this angle is the same as this one, this angle is the same as that one, right? This is angle A, angle B, and this angle C. Angle A, angle B, and angle C. Okay, I know that angle A for either triangle, angle A plus angle B angle A plus angle B plus angle B plus angle C equals 180 degrees, right? So if I know that angle A and angle B are equal to each other, right? I'm gonna do this, okay? I'm gonna do this. I'm gonna call this ABCD. I'm gonna call this D, E, and F. All right, so I'm gonna say angle AD plus angle E plus angle F equals 180 degrees. Okay, I know that angle D, plus angle E, I'll just say that angle D is congruent to angle E, is congruent to angle A, and angle B is congruent to angle E. Right, so I know now that I can say that angles I can do some substitution. How do I want to do this? Let's see, I'll do it this way, I guess. I'll do angle D plus angle B plus angle C equals 180, and then I'll say angle D plus angle E, and then I'll say angle D plus angle E plus angle F equals 180. All right, so like I said, if it's not intuitively obvious here, like if this one and this one and this one and this one, right, are equal, then the only one, then this one has to be equal. I'm showing the math that shows that. Okay, so here we go. So if this equals that and that equals this, I can say, hey, this is the same thing. So I'm going to set this equal to that. What is that? Well, remember that's the transitive. And I'll say angle D plus angle E plus angle C equals angle D plus angle E plus angle F. All right, so this was substitution. right here. This was substitution. Substitution property of equality, and this was transition property of equality. And now I can take this like black pen here and subtract D from both sides and E from both sides. And I'll just say now angle C equals angle F. Right, so now because of this, I have to say that the third angle must be true because it's the only one that's left. Maybe zoom out a little bit so you can see all that work there. All right, so that is that's the proof there that says, that kind of shows that, you know, that has to be true there. Okay, so you just take out this angle side angle. That's just angle angle, right? So if you have two angles in a triangle that are congruent, then those two triangles are at least similar, right? Two angles that are congruent, then these two triangles are at least similar. And that's called angle similarity theorem. Okay, so that's one of them. And then the other two are really familiar, right? This is side, 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 and side, angle, side. Side, angle, side. Similarity, triangle, 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 similarity theorem. Okay, so here, this is one saying that the lengths of the corresponding sides of two lengths of the triangle of proportionality, or of two lengths of the triangle of proportional, then the sides are similar. Okay, so instead of, I don't know why they call this side, side, side proportionality. It should be just like side, side proportionality. But this is saying if, let me zoom out. So if the lengths of the corresponding sides of two triangles are proportional, then the triangle, this is our three sides. So you need two sides proportional. Proportional, I guess, is the main thing there. Proportional. Then the triangles are similar. I'm just going to start writing that in Mathanese so you understand the symbols are similar. Okay, I'm just going to pause this for a second because I'm going to never mind. All right, we'll pause just for a second. I thought so, I just wasn't sure. So the proportional symbol is kind of like an infinity symbol, except that was awful. Except it has an open end. It kind of looks like a fish. That's the proportional symbol. Yeah, so if two sides are proportional, then the triangles are congruent, similar. So proportional, so that means that's what we're talking about over here. So for this instance, like if A and B, let's say A to B equals 1 to 1. So X to Y is 1 to 1 because this is 4 to 4. 4 to 4 equals 1 to 1. 8 to 8. 8 to 8 equals 1 to 1. Right? That is the same fraction, same proportionality. Right? So that means that those are proportional. Okay. So the same fraction are the same proportionality. I'll just say same fraction. Right, and then we have the side angle side theorem, and if two sides are proportional and they're congruent, and their included angles are congruent on two different triangles, then the triangles are similar. Let me pause that for a second and ponder that. All right, so this one is not just the proportional, not just any sides. This is the corresponding sides. This is the corresponding side. The two triangles are proportional, right? So they got to be like this one and this one and this one and that one, or this one and that one and this one and that one, right? That's the corresponding sides. So this one is saying the lengths of two sides are proportional and their included angles are congruent on the two different triangles, and the triangles are similar. So let's look at that one more in detail here. Just let me find an example real quick. All right, so I'm going to correct myself in the last one. I misread my notes from earlier, way earlier, and it's the for the side. It's if the three lengths of the sides and the corresponding sides from the other one, which makes way more sense, which is why it's called the side. Like I said, it's late on a Sunday evening. All right, so if the three sides of all three triangles of corresponding triangles three sides, and just write this whole thing over.
What are you doing?
All right, so side. Similarity theorem from the top states that if the three sides of a triangle are proportional to the corresponding sides of another, those triangles are similar. Okay, so this one is saying that for AB, so I'd also have to add for the 4 to 4, 8 to 8. What am I doing here? This is not true at all. Man, what am I tired? Okay, so this is wrong too. All right, so it's not be A to B. This is, all right, so this would be, man, I'm tired. All right, so this is AB over XY. This would be AB over XY. This would be 1/2. Man, this was wrong. All right, and then this would be CB over ZY. This would be CB over ZY, and that would be 4 to 8. 4 to 8, which would be 1/2. All right, so this would be 4 to 8. 4 to 8, which is 1/2. I don't even know why that didn't even seem wrong to me. Okay, and then the last one would be, AC. I'll do it up here. AC to XZ. X. I don't have yellow. Here's an orange. XZ. AC over XZ, which would be 4 square root of 2 divided by 8 square root of 2, and that would be, again, 1/2. Man, it's been a long day. Alright, so sorry about all that confusion. That was hopefully better explained there. Okay, so then we have the side angle side triangle congruency postulate, or triangle similarity theorem. So this one says if I have two sides, if the length, I'll just say two sides. If two sides, I need two sides, and the angle, two sides proportional. Two sides proportional, and the angle in between equal, then the triangles are similar. Okay, so I have, I'll do an orange triangle this time. Got an orange little triangle like this, I guess. And then a bigger triangle like this, I guess. Something like that. Okay, I don't know if those are actually similar. Right, but let's say that this angle, we'll say that this is, we'll say this angle here and this angle here are congruent, and we'll say that this is 4, this is 6, this is 5, and what would this need to be in order for these two triangles to be congruent or similar? What would these two triangles need to be similar? So we'll call this triangle A. A to B, C, X, Y, and Z. All right, so A to B, A to C over X to Z over X to Z equals 4/6. 4/6. Okay, so this one to this one equals 4/6 or 2/3. Okay, so maybe we'll make this. Maybe we'll make this 6 for the math. It'll be easy for me in the morning. All right, so if this is 2/3, okay, what would this need to be? X to Y. What would X to Y need to be? So A to B equals 6. X to Y needs to equal that. So we need to cross multiply to figure out what X needs to be. All right, so we go X times AB equals XY times 6. Right, XY our value for A to B, or sorry, this was 4/6, right? So this is the ratio we should have set up, right? So 4/6 is the ratio we should have set up, because that was our small triangle to our big triangle. Our small triangle was AB, that's on the top. Small triangle, big triangle, that's the ratio that we set up. That's so cool, right? So then we cross multiply, right? So it's 4x equals 6 times 6, which is 36. Okay, so now we just do 36 divided by 4. 40 or 36 divided by 4, and that equals 9. So x equals 9. So in order for these to be similar triangles, x would have to equal 9 there. All right. So we showed you a little bit about proportionality. Showed you how to identify similar triangles and write similarity statements. So writing similarity statements, we would all have to say, in order to write that these triangles are similar, I'm going to write this is a similar, this triangle is similar to this triangle. You ready? Right, ready for it? We're going to say A, line up the vertices just like you would for triangles. A, B, C, X, Y, Z. X, Y, Z is congruent. There, instead of congruence, you write the similarity symbol. Alright, so we did that. Now what else do we need to do? And then we need to show that the two are similar. Right, and this is how you show that they're similar. You either pick big over small or small over big. It doesn't matter as long as you keep it consistent. Right? And then you compare the fractions to each other, right? Either using the side, not the side, the side. You need 3 of them. The side angle side, that's the 2 sides, and the angle in between. It has to be the angle smushed in between, or the angle theorem. Okay, and I proved the angle theorem here. Okay. And we also talked about how to figure out proportionalities, and a little bonus showing how to cross multiply to determine what length the line segment needs to be in order to show that a line segment needed to be congruent. I hope that worked out, and I'll post this here shortly. And again, sorry for the confusion there with the side thing and the math up here.